Dear students, in this lecture, let us discuss on basic processor architecture. And this is the block diagram of basic processor architecture, and it comprises of main memory, processor memory interface, program counter, instruction register, control unit, ALU unit, as well as general purpose registers involved in a single processor. And the main memory holds the operands as well as the program for execution of the current instruction, as well as processor memory interface. It acts like an intermediate to communicate between main memory as well as the processor memory interface. The program counter, it points the address of next instruction to be fetched and executed. Instruction register, that holds the current instruction that is currently being in execution. The general purpose register, it acts like a high-speed storage element in order to store the data or instruction. The control unit, it generates the control signal, and also it holds or controls the activity throughout the entire blocks involved in a processor. And the ALU unit, it performs arithmetic as well as logical operations when the program is being executed. The basic processor architecture. So the first one is ALU. The ALU stands for Arithmetic and Logic Unit. It performs the basic arithmetic operations such as addition, subtraction, multiplication, division, as well as the logical operations such as and, or, not, etc. And these operations, to be performed, it has to fetch the operands from the main memory, and it has to brought into the high speed storage element called registers, which is given as a block in the processor. Next is control unit, and it coordinates as well as controls the activities among the functional unit, and its basic function is to fetch the instructions stored in the main memory and to identify the operations and the devices involved in it, and accordingly it will generate control signals to execute the desired operations. Next is instruction register, and it holds the instruction that is currently being executed, and its output is available to the control circuit, which will generate the timing signals to control the various processing elements involved in execution of the instruction. Program counter is another specialized register, and it points the memory address of next instruction to be fetched and executed. And during the execution of an instruction, the contents of PC are updated to the corresponding next address when the next program is in pipeline. The PC points to the next instruction that is to be fetched from the memory. General purpose registers, and its function is to store as well as hold the operands that have been loaded from memory for processing. And processor memory interface, the processor memory interface is a circuit which manages the transfer of data between main memory and the processor. If a word is to be read from the memory, the interface sends a address of that word to the memory along with the read control signal, and the interface waits for the word to be retrieved and then transfer it to the register. If a word has to be written into the memory, and again the interface transfer both address as well as the word to the memory along with the write control signal. And this is an example of an instruction. To perform a given task, an appropriate program consisting of list of instruction is stored in the memory. In order to process this instruction, load R2, LOC. The processor, it reads the content of memory location whose address is represented by the label LOC, and it fetches the data from the memory and loads them into processor register R2. The original contents of location LOC are preserved, whereas the register R2 whenever it is having a value, it is replaced with the value which is fetched. And these are the steps for execution of the previous instruction load R2, LOC. And first, the instruction is fetched from the memory into the processor. Then, for the LOC, the operand has to be fetched from the memory into the processor. And finally, the operand is stored into the register R2. So, after operands have been loaded from the memory into processor register, the arithmetic or logical operations can be performed on them. Example, add R4, R2, R3. So here the contents of register R2 and R3 are replaced by the sum value into the register R4. So the operand in R2 and R3 are not altered, but the previous value in the R4 is overwritten by the sum value of R2 and R3. Once the desired operation is performed, the result can be stored into processor register, and this can be transferred to the memory using the instruction store R4, LOC. And this instruction, it copies the operand in register R4 to memory location LOC. Then the original contents of location LOC are overwritten, but those of R4 are preserved. For load and store instruction, the transfer between memory and the processor are initiated by sending the address of desired memory location to the memory unit and asserting the appropriate control signal. The data are then transferred to or from the memory. Operating steps for execution of the program. First, the program must be in the main memory in order for it to be executed, and it has to be transferred there from secondary storage through the input unit. And the execution of the program begins when PC is set to the point to the first instruction of the program, and the content of the PC are next transferred to memory address register, and a read control signal is sent to the memory. After this, when the addressed word has been fetched from the memory, it is then loaded into instruction register. At this point, the instruction is ready to be interpreted and to be executed. If the instruction involves an operation by the ALU, it is necessary to obtain the required operands. An operand in the memory is fetched by sending its address to the memory with an initiating a read cycle. After fetching the operand from the memory, it can be sent to the ALU to perform desired arithmetic operation. Then the result is sent to the processor register. There, the result is written into memory with a store instruction. It is transferred from processor register to the memory along with the address of location where the result is to be stored with the write operation initiated. Then the content of PC is incremented to the next instruction when the current program or current instruction has finished. While the normal execution of the program, while it is being executed, it can be pre-exempted or it can be paused. If some devices require urgent servicing, to do this, one device raises an interrupt signal, and this interrupt signal is a request signal from an input-output device for service by the processor. So the processor provides a requested service by executing an appropriate interrupt service routine. While this diversion taking place, the internal stage of the processor and its state must be saved in the memory location before the interruption for preservation of the current instruction which is being take place, and the information that is saved includes the content of program counter, and the content of general purpose registers and some control information involved in it. When the interrupt service routine service is completed, the state of processor is restored with the current execution of the program. The basic performance of the process is evaluated by how faster the processor could process a single instruction in a single clock pulse, and the processor clock is nothing but it is a controlled circuit which could able to generate the timing signal called clock and the regular time intervals called clock cycles. To execute a machine instruction, the processor divides the action to be performed into a sequence of basic steps that each steps can be completed in one clock cycle, and the length of one clock cycle is an important parameter that affects the processor performance. And the older processor version, which was used in personal computers as well as the workstations, it had the clock rates ranging from very few hundreds of megahertz to around 1 gigahertz, and the modern processor that has evoluted to clock rates ranging from 1 gigahertz up to around 5 gigahertz or even higher with the turbo boost technologies. The basic performance of the system is evaluated by program execution time is given by the formula T equal to N into S divided by R, where the T refers to the processor time required to execute a program and N denotes the actual number of instructions to be executed. S refers to average number of basic steps needed to execute one machine cycle instruction, and R refers to clock rate in cycles per second, and the execution time can be given by instruction count into CPI divided by clock rate, where CPI refers to clock cycles per instruction. And these are the reference book I have gone through. Thank you.